Hey mathematicians, let's do your homework. Shout out to Estela for reminding me. We had our shortened schedule today. We had our incentive and I totally forgot about the video. So thank you, Estela, for reminding me. Let's do your homework. Good thing we have all weekend. Okay, I also am recording at home and I do not have my stylus and my tablet to write them with, so it's going to be a little bit different today. But our first problem is about marbles. We've got red marbles, we've got blue marbles, and we are looking for a jar that could possibly have 15 red and 12 blue. So we've got a bunch of options. What I'm looking for when I'm looking for potentially the right answer is I need to choose numbers where if I have my red number, which since it says red is the first number, I'm looking for things that 15 is in that times table. So let's see how clunky my drawing is going to look. Here I have 3, 6, 9, 12, 15. Okay, that could work. There is not a whole number that you can multiply 4 by to make 15. So ratio 2 is out, or jar 2. You can multiply 5 times something to make 15, so jar 3 is still an option. You cannot multiply 7 by a whole number that makes 15. So jar 4 is out. Now I'm going to look at the other one. Oh boy. You can multiply 2 times something to make 12, and you can multiply 4 times something to make 12. So both of them are looking like contenders, but it has to be the same scale factor for both parts of the ratio. So I can't say like, oh, I'm multiplying my red ones times 5 and my blue ones times 6. That does not work. It has to be the same number. And by the way, I just said the numbers for jar 1. 3 times 5 makes 15, but 2 times 5 does not make 12. So jar 1 is not going to work for us. Just to prove it, oh look, when I record from home, you hear a cat fight in the background. Mouse is not being nice. Just to prove it, 5 times 3 is 15. 4 times 3 is 12. So since it's the same scale factor, that makes jar 3 our answer. Okay, next one. Scrolling. Oh dear. Technical difficulties. Scrolling. There we go. Look at the table of the costs for different sized bottles of salad dressing. Which one is the best buy? When we talk best buy, it means the cheapest for every one of whatever it is we're buying. We're buying things, salad dressing, which we're measuring in ounces. So we're looking for the cheapest per ounce. That means I have to divide in order to find the cheapest per ounce. The best buy is the one that either when they're both the same price gives me more, or when they're all the same amount, when they're all 1 ounce, is the least expensive. So you would take your dollars because we're always comfortable breaking money up. We're not necessarily going to go into a store and be like, I'm going to pour out the salad dressing because I only want this much. So you're going to divide 120 cents or $1.20. Oh yes, I hear you, mouse. By 12. Now doing this on the trackpad, it takes me a really long time to draw this, so I'm not going to draw out all the division problems for you, but you would set up each division problem and put the money inside and the ounces outside and divide them. It may actually take you to the thousands place because we're thinking about money not in the written sense, we're thinking about it in the actual numerical sense, and then you would potentially round to the closest cent to compare them. All right, number 3. We're looking for the one that does not belong in the table. It will not belong if it doesn't follow the same rule as what you're given at the beginning, at the top. So looking for rules between x and y, I'm going to start with x because it's my independent variable. How do I get from 2 to 8? Again, these rules are only multiplicative, so only a times or a dividing rule. 2 times 4 is 8. 1 times 4 is 4. 3 times 4 is 12. Oh, look, here's Mouse. Say hello, Mr. Mousey. He says no, he doesn't want to say hello. He wants to run around crying. Okay. So it looks like our relationship is x times 4 makes y. So here you can see 5 times 4, yep, that makes 20. 9 times 4, ooh, that also makes 36. Don't get excited. That's not our answer. We're looking for the one that does not follow that rule. So A is out. You can check this option B. I'm going to do one of the multiplication problems with you. Personally, when I'm doing a 0.5 times something, I just start doubling it. Times 4 means you double it twice. And 2.5 plus 2.5 makes 5. 5 doubled is 10. So this one works. 2.5 times 4 does equal 10. So you want to check every single option. Maybe even your answer choice that has something wrong with it, one of them will be right and one of them will be wrong. So you need to check literally every single option. Number 4. The ratio of boys to girls in the school band is 4:3. Since boys came first, the 4 is boys, girls came second, the 3 is girls. There are 28 total students. We did a problem like this in class today where I gave you both the parts and you need to add them together to find the total. So 4 plus 3 is 7. Oh my gosh, different context, but actually same numbers as the problem we did in number 2 in our packet today. So 4 plus 3 makes a total of 7. So then when you set up a proportion, oh gosh, it's hard to draw on the trackpad. When you set up a proportion, there's my 7, there's my 28. They need to be on the same level. How many girls? So now I'm going back to my original ratio. The 3 is the girls. I'm going to put it on top of the 7 since the 3 plus 4 is what made that 7. And then you are going to find a scale factor and find the missing amount. Number 5. If the, oh my God, mouse gave me a cat hair in my mouth. Ew. If the ratio of the number of small dogs to the number of large dogs in an animal shelter is 9:5, which of the following is possibly the number of small dogs and large dogs in the animal shelter? Same as number 1. I'm starting by checking, okay, small dogs is the first thing I said, so small dogs is 9. I can only have options that are in the 9's times tables, that are multiples of 9. So 9 times something makes 10? No, it doesn't. 9 times something makes 18? Yep, that's an option. 9 times something makes 15? Not a whole number. 9 times something makes 32? No. Didn't even have to check my 5's tables, but just double check. 9 times what makes 18? 9 times 2. And 5 times 2 also makes 10. All right, now we're moving on to graphing. Oops, which is not in the same file. Here we go. Graphing. Parallelogram ABCD is shown on the coordinate grid below. Which of the following is not the coordinates of a vertex? Vertex means a corner of a shape. So these big black dots, those corner dots, that's what we're talking about. So I'm asking you which of those ordered pairs does not match up with one of those corners of this parallelogram. So it could be like inside the shape, it could be outside the shape, it could be on the line, but not one of the corners. So you need to plot all 4 points, and 3 of them are going to be like, oh, look, it's right here on the corner. And one of them is going to be like, oh, that's weird. And you want that one as your answer. Number 2. Which point, oh, meow, meow, Mousy is very talkative at night. Which point has the coordinates -2, -2.5? Well, it's going to be in my favorite quadrant, all negatives. So we are only looking at E or D because F is in quadrant 2, G is in quadrant 4. They would have 1 negative, 1 positive each. The only 2 options are E and D, and you need to decide which one aligns vertically with 2 because 2 is our X coordinate, which means we are looking at this 2 right here. 2.5, the -2.5, is going to be on our horizontal line, which is a little confusing because it's not the horizontal axis. We're going to go down, 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 find -2.5. And I think you can tell which point matches up at the intersection of those 2 lines. Number 3. Which coordinates represent the endpoints of the segment graphed below? So again, endpoints, we're looking at those dots A and B. I don't care if it's somewhere else random. I don't care if it's on the line. I am only looking for the answer choice that matches point A and point B. The ends, the start and the beginning of that line. Number 4. Which ordered pair is located on the x-axis of a coordinate grid. Oh, actually, this is number 9 because I think I handwrote the numbers for you. The x-axis goes this way. So you should not pick anything that has a y value because otherwise it would be above the x-axis or below the x-axis. You want something where y equals 0 because it has not moved up or down. I only see one option like that. And the final problem. Which statement is true? If a point has coordinates 0 and b, where b is a positive number, so basically we're saying like go left or right 0 and then go up, is that point on the x-axis? We just said in the problem above that something on the x-axis goes up or down nowhere. Like it does not move up or down, it stays on the x-axis. It can move side to side, but can't move up and down. So that is not true. If a point has coordinates a and b where a is bigger than b, it must be in quadrant 1. Well, I can think of an example where a is -1 and b is -7. That would be in quadrant 3, but -1 is bigger than -7, so no. If the point has coordinates a and b where a is less than b, then it must be in quadrant 4. Can you think of an example where there's a number that's less than another number, but they're both positive? Yeah, 2 is less than 3. Those are both positive. That would be in quadrant 1. If a point has coordinates a and b where a and b are equal to each other, but they're not 0, then it must be in quadrant 1 or in quadrant 3. Think of an example about two numbers that are equal to each other and you can choose anything except for 0. 2 and 2. Those are both positive. That would be in quadrant 1. -5, -5. Those are both negative. That would be in quadrant 3. If they are equal to each other, you cannot have one that's positive and one that's negative. They have to both be the same sign. So that means it's either going to be in quadrant 1 or quadrant 3. And now we're done with our homework. One more shout out to Estela for reminding me because I might have had West Wing. I forgot about the homework video. So thanks for reminding me, Estela.